for notes solving quadratic equations using the calculator. Okay, so let me talk about what we did before this. Guys.
You can hide it.
Stop. Oh, yes, if I can. Okay. What we did before this was we found the roots. Do you remember what roots means?
Yeah.
What's roots mean?
X-intercept.
X-intercepts. Okay, so we were finding the roots, the x-intercepts, by doing what?
Factoring.
X factor. Good. Okay, so we were doing the roots by doing X factor. We put our two missing numbers in the parentheses, and then we solved. We set them equal to 0, and then we solved. Remember this? Okay, I taught you how to do it by hand because I told you you need to know how to do this when you go to Algebra 2, college algebra, all that fun stuff, right? Okay, but for my class, we have to take the STAR test, right? And we get to use the calculators on the STAR test. So I also, not only do I show you by hand so you can be successful after this year, I'm also going to show you how to do it in the calculator so that you can use it on your STAR test and make sure that you get the right answer. Make sense? Okay. So we are going to do this in the calculator mode. So it says there are several different methods to solve quadratic equations. We will focus on 2 of them. One way is polynomial tools, which you guys don't know how to do that. I'm going to show you in just a minute. Another way is by graphing, which we all know how to graph. Okay, but I am going to show you one extra tool in the graph that we can use to help us. All right, it says reminder, if you're finding the solutions. What does solutions mean?
Multiple.
If you're finding the solutions to a quadratic equation, you're finding the x-intercepts. Okay, up here, y'all see rocks?
Yeah.
Right? Rocks, we've talked a lot about rocks this unit. Right? Roots means what? X-intercepts. Zeros mean what? X-intercepts. X means x-intercepts. S means solutions, which means x-intercept. Okay, so all of those words all mean the x-intercept. So it says if you're finding the solutions, which means x-intercepts, then you're finding the x-intercepts, and quadratic functions can have 0, 1, or 2 solutions. And what does solution mean? X-intercept. Okay, so we can have 0, 1, or 2 solutions, x-intercepts. All right. So let's talk about what 0 solutions looks like. Let's talk about what 1 solution looks like, and let's talk about what 2 solutions look like. So if I sketched a graph, x and y, okay, and I had 0 solutions, 0 x-intercepts, that means that my U shape would look something like this. Okay, does it cross the x-axis? Is this something that we've seen? Yes, we've seen something like this. Okay, does it have to be in this quadrant and going up? No, it could also be like this, right? It could be anywhere as long as it's not touching the x-axis. That would be 0 solutions. It never touches the x-axis. Does it not have any x-intercepts? Another one, okay, if we had 1 solution, that would be if our vertex touched the x-axis at one point. That means that we have 1 solution. Does it have to be going up, and does it have to be on this side over here? No. It could also be going down. As long as the vertex is the only thing that touches that x-axis, that means that it would have 1 solution. Does that make sense? Yeah. Okay, and then 2 solutions is what we've been looking at so far. X, Y. 2 solutions would be just a regular U. Right? 1 solution, 2 solution. Okay, so those are the different types of solutions you can have. 0 solutions if it never touches the x-axis. 1 solution if the vertex touches the x-axis. Or 2 solutions if it looks like this. Does it have to be going up? No, it could also be going down and have 2 solutions. Okay? Are you with me? So those are the different ways we can have 0, 1, or 2 solutions.
Can it be more than 1 or 2 or no?
Not for quadratic. You can have more, but that would be x cubed. Okay, so whatever that squared is, okay, it wouldn't be a quadratic. It wouldn't be a U shape. Says the polynomial tools method is best used if the quadratic equation is in standard form. And I have a typo on this, so make sure you look up here so we can fix it. 8x squared plus bx. That should be bx plus c. Okay? That's my fault. So, standard form of quadratic equation is ax squared plus bx plus c. The graphing method is best used for any other form of the quadratic equation. So I want you to underline polynomial tools. When we do polynomial tools, that means that we have no parentheses in the equation. When we do graphing method means we do have parentheses. Okay? So that's going to help us. Levi, look up here. You should be writing what I'm writing. That's going to help us. Hello. You should be writing what I'm writing. That's going to help us determine if we're going to use polynomial tools or graphing, if it's got parentheses or if it doesn't. Okay? In order to use either method, the equation must be set equal to 0. All right, so look at example 1. Does this have parentheses?
No.
No. So which method am I going to use? Poly tools. Okay? So write poly tools. Now, in order for me to use poly tools, my equation must be set equal to 0. Is this equal to 0 right now? No. What's it equal to?
75.
So what do I need to do? Move it. Okay, we got to move it to the other side. So how do I move a positive 75?
Negative 75.
Minus 75. Does it have a like term that I need to write it under over here? The 3. So minus 75 under the 3. All right. 75 minus 75 gives me 0 equals, and then I have 2x squared. What's 3 minus 75? Negative 72. Okay. Now, before I show you how to do poly tools, look right here. Are you looking? Right here. How many terms do I have for standard equation? X squared is 1, bx is 2, c is 3. Okay? Right here. How many terms do I have?
2.
2. So which one am I missing?
The middle one.
I have the x squared, right?
Mm-hmm.
Do I have the regular x?
No.
No. Do I have just the number?
Yeah.
Yes. Okay, so my a number is what?
2x.
My a is the number that goes with the x squared, which is 2. What's my b number?
0.
I don't have a b, so we say that's 0. And what's my c number?
So, negative 72.
Negative 72, just the last number by itself. Okay, now let's do this in poly tools. So turn your calculators on. Do this with me real quick. So turn your calculators on. Go to regular calculator mode. Everybody should be doing this with me, so we all know how to do this in the calculator. Okay, I'm in regular calculator mode. Now I want to do poly tools, so hit menu.
Mm-hmm.
What class are you in?
Algebra.
Algebra. Okay, real quick. When do we use and solve
Just define it.
regular x with no exponent, right? Regular x and an equal sign, and it says solve. That's when we use and solve. When do we use solve systems? When you have 2 equations. Are we doing 2 equations right now?
No.
No. I've had a lot of people try to do this in systems. We don't have 2 equations, okay? And polynomial tools is what we're doing right now. So hit number 3.
3.
Now, roots. What does roots mean?
X.
X-intercept. I'm trying to find my x-intercept. Okay, that's what our goal right now is, to find our x-intercept. So number 1. Okay, everybody hit number 1?
Okay.
Okay, this page is never going to change. 2 in real stays the same. So go down and hit OK. Now I got my 3 boxes. What's my first number?
2.
We said we don't have a b, which is 0. And then my last number, make sure you do negative 72. If it's a negative sign in there, you got to make sure you put that negative with it. Don't do a minus. It won't work. Okay? Hit enter, enter.
What we just said, okay.
2x squared minus 72. It looks the same, so I'm good there. Then I'm going to hit enter again. Okay. So this pops up, right? What are we trying to find? Our x-intercepts. Negative 6, 6. If I was to plot negative 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right here. Is that an x-intercept? No. Okay. Negative 6, 6 is not an x-intercept. So is this an ordered pair? Are these parentheses?
No.
No. What are they?
I don't know.
Brackets. Right? Okay, in order for it to be an ordered pair, it's got to have parentheses. These are brackets. So negative 6 and positive 6 is a list of numbers. Okay? It's a list of our x-intercepts. Instead of writing two separate ordered pairs, it writes it like this to save room. Okay? So right here, my answers are, my x-intercepts are negative 6, 0, and positive 6, 0.
Oh, okay.
Okay, it's a list of my x-intercepts. It's not an ordered pair. Everybody understand that?
Yes.
Okay. All right, the next one we're going to do is example 3, right underneath it. Okay, this is where I'm at. Example 3, right underneath the one we just did. Okay, does this have parentheses? No, so how am I going to do this problem? Polynomial tools. Okay? Am I ready to plug this into polynomial tools?
No.
Why not?
It's not equal to 0.
It's not equal to 0. So what do I need to do with this negative 5? Move it to the other side. Make sure you're writing this down. Levi, write with me, bud. Does it have a like term over here? Nope. So I'm just going to, it doesn't matter where I write it. Okay. Negative 5 plus 5 is 0 equals. Freeze and look up here. It is important, listen, that you write these in the correct order. Okay, because when you plug them into those 3 boxes of the calculator, that A, B, and C, it's important that you have them in the right order. So when you write this, you always write whatever the x squared is first. So this is a 2x squared first. Then, after the 2x squared, I write the number with just the x. So 7x. Because that's going to be my bx. Right? And then I do just the number, which is a positive 5, last, because that's my c. Okay? So x squared first, then regular x, then the number. Got it? Okay, you have to write them in that order. So I've got it set equal to 0. We're going to go plug it in Poly Tools. So hit Menu. Do it with me. Algebra. Poly Tools. And I'm trying to find the roots. Find the x-intercepts. 2 in real, stay the same. And then I've got my 3 boxes. What's my first number?
2.
Second number?
7.
And
5.
5. Enter, enter. Enter again. Is this an ordered pair?
No.
No, it's a list of numbers. So negative 5 over 2, comma 0, and negative 1, comma 0. Questions? How do we feel? Feeling good? Okay. Number 2. Go back up to the top. Does this have parentheses?
Yes.
So how do I have to do this?
Graph.
Graph. So everybody write graph. Do I need to solve for 0?
No.
No. Okay, I'm going to show you something new in the graph, so it's important that you graph with me, okay? All right, go to a graph. Do it with me. Ethan? Are you with me? Okay. All right, plug it in exactly how it looks. Parentheses, x plus 3 squared minus 4. Now, remember, right here, f of x equals means what?
Y.
Y equals. I already have my equal sign in this problem. I don't need another equal sign. I'm not going to do the equal 0. Okay, if you do equal 0, it's not going to work. Everybody got it? You can't do equal 0. I already have my equal sign right here. Okay? All right, hit enter. All right, now, this one is an easy one because why? It's right through a perfect point, right? It hits those dash marks. I could count that this is -1 and -5. All right? Is it always going to be like that? No. So now I'm going to show you how to find these when it's a decimal point or if you have to count a bunch over. Okay? What does trace mean? If I say I want you to trace this.
Trace the line.
Okay, so let's say I had a picture of a flower on my paper and I wanted you to trace it. What would you do?
You would put the paper over.
You'd put a new paper over it and you would trace the lines, right, of the flower. Does that make sense? Everybody knows what trace means. So what we're going to do is we're going to trace the graph. Okay, we're going to follow the lines on the graph. So I want you to hit menu. 5. Does everybody see trace? 5. And then we're going to hit number 1, graph the trace. Okay, so this little X should show up with a dot. All right? In order for you to trace it, to move the X, you can only hit the left and right arrows. Okay? If you try to go up and down, it's not going to work. You can only hit the left and the right. So I want to move this X to my X-intercept. So that's to the left, so I'm going to hit the left button. And then look what pops up. Does everybody see this right here? 0. What does 0 mean? X-intercept. It's on the rocks, right? Zeros is part of my rocks, which means X-intercept. So my first X-intercept is this ordered pair right here. -1, 0. Then I'm going to keep hitting the left button till I get to this X-intercept. Until the 0 pops up again. Okay, does everybody see where it says 0? Once it says 0, I know for sure that's my X-intercept, which is -5, 0. And those are my 2 X-intercepts. Any questions?
No.
Easy peasy? Okay, look at number 4, right underneath it. Is this going to be a polynomial tool or a graph? How do you know? It's got parentheses. What is find the roots? What's roots mean? X-intercept. Right? I'm trying to find the X-intercept. So we need to go to a new graph. Okay? And I'm going to plug it exactly how it looks. Parentheses, x plus 1 squared minus 36. Enter. Okay. Again, it's a perfect point, but I still want to work on our tracing so we can all understand how to do that. So hit menu, trace, graph trace, and my X pops up. So I'm going to go to the right this time. I think if you hold it down, it works. But if you hit it a bunch of times, it will lag, and then it will go really far. Okay. All right. So my first point that my X hits when it says 0 is 5, 0. Now I need to go to the left side. So I'm going to keep hitting it until I get all the way to the other 0. Don't hit it a million times or it'll lag. Okay, look up here. Look up here. What is this? Y-intercept. So not only does it tell you the zeros, it tells you the y-intercept. If I go a little bit further, what does minimum mean? My vertex, right? What if the U went the other way? It would show maximum, which is your vertex, okay? Okay, keep going because I want the roots, or the zeros. And my other 0 is -7, 0. Questions? Are we good? Yeah. Okay, look at number 5. Find the zeros. What's zeros mean? x-intercept. Okay, so does it have parentheses?
Yes.
Yep, so this is going to be a graph. I'm going to plug it in exactly how it looks. 9x minus 5 times 4x minus 1. Skinny mini, right?
Yes.
Okay, so now is this one a perfect point? Does it go through a dash mark? No, so this is where trace really comes in handy. Okay, so I'm going to hit menu, trace, graph trace. And I'm going to scroll down. My first 0 is 0.250. And then I hit it again. Tells me my minimum, which I don't care about right now. And then my second one is 0.556, 0. Questions? Questions? Are we good? Everybody understand how to do trace? Yes. I don't know. I think it's like super close to 0. But because it says 0 and this is my x, that's the number I'm going to use. Okay?
So if it has the e and says minus 12 is equal to 0?
Yes, don't worry about that. Just worry about the x when 0 pops up. Okay? Okay, number 6. Is this going to be a graph or polynomial tools? Poly tools, how do you know?
Does it have the parentheses?
Perfect, does not have parentheses. Is it ready to be put into polynomial tools?
No.
No, what do I need to do? I need it to equal to 0. Okay, I'm going to get rid of the negative 2x first. 2x squared. How do I move a negative 2x squared?
Positive.
Add 2x squared. Does it have a like term? Which one? 10x squared. So that's where I'm going to write it. I'm going to write it underneath that one. 10x squared plus 2x squared is 12x squared minus x minus 2. These cancel. I'm bringing everything down. Minus 6x. How do I move that negative 6x? Add 6x. Does it have a like term? Negative x. So I'm going to write it underneath that one. These cancel, give me 0. 12x squared gets brought down.
5x.
Negative 1 plus 6 is positive 5x. Minus 2 equals 0. Okay, once it equals 0, then we can plug it into Poly Tools. We go to regular calculator mode. Menu, algebra, Poly Tools, find roots. 2 and real stay the same. 12, 5, negative 2. Enter. Make sure it looks the same as my paper. And it gives me my list of numbers. Negative 2 commas 3, or sorry, negative 2 over 3 comma 0, and 1 over 4 comma 0. Okay. How do we do? Good? All right, let's talk about something. Could I graph this right here? Can I graph this?
Yeah.
And then what?
Trace.
Would that work?
Yes.
Yes. Could I put this in a polynomial tools? No. Because it's not A, B, and C form. Okay, it's got to be A, B, and C form. So technically, I could graph any of these. Parentheses or no parentheses, right? And then do trace. Okay? But for polynomial tools, it cannot have parentheses. It's got to be in the A, B, and C form. So you understand?
Yeah.
So if you would rather graph them all, you can do that. Or if you want to do poly tools for the ones without parentheses, I'm okay with that. It's up to you. Any questions?